Now let me go a little bit more into the null hypothesis. It's very important. Um, it's a critical statistical concept. And what it means is that we're looking for no difference between groups. Let's say, I'm going to give you an example in just a little bit. Okay, so we're looking for no differences, no difference between groups. So whatever our groups are, it assumes the null hypothesis that the groups and or things that we are examining are not different from one another. All things being equal, the bell-shaped curve, the numbers, the data will be the exact same thing. There will be no difference at all from one another. When we develop a study, we hope to reject the null hypothesis so that we can say that our study, intervention, or experiment made some kind of difference in our subjects. And hopefully that will become a little bit more clear as I go along. Let me give you an example of a null. This is actually from my dissertation. So there will be no significant difference. Okay, that's a critical language right there. When you write your null hypothesis for your chapter 1, it needs to be in this format, no significant differences. Because you can have differences between people or groups or things that you're measuring, but they may not be significantly different. We'll talk about how we know something is significantly different. As we're talking about statistically different from one another in just a little bit. So there will be no significant differences between, okay, so I have groups here, novice and experienced athletic training students. Those are some variables. Now, are they independent or dependent variables? Let you figure that out. Participating in an undergraduate level KHEP, accredited athletic training education program, that's what ATEP stands for, and the total professional socialization variables as measured by the ATPSI. That's the name of a survey instrument that I developed, a questionnaire. It's the ATPSI stands for Athletic Training Professional Socialization Index. Okay, so the question, what the hypothesis is that there's a whole bunch of stuff in here. Okay, so we got variables, we got novice and experienced athletic training students. These are delimited individuals. I've delimited them by saying that only individuals that are undergraduate entry-level athletic training students that are participating in a KHEP accredited athletic training education program. KHEP is an accrediting body. Sort of like in athletics would be the NAI or NC2A, and at K through 12 and university would be a WASC, does the accreditation. In athletic training education programs at the time of the study, KHEP was doing the accreditation. Now it's KATIE. Okay, so those are all delimitations. Those are the delimitations that I put on my subject. I only wanted these type of individuals in my study. Then in the total professional socialization. Now, professional socialization was one of the variables I was measuring, and I measured that by using this study. So that's the dependent variable because I measured that. Novice and experienced are my two levels of independent variables. So in this, the big picture is that I'm saying in my study, my research question was pretty much the same thing. My hypothesis is that there will be no difference between these groups because we want to say that there is a difference. Statistically, how we run the statistics is is assumed that the groups are the same or different. Excuse me. It's assumed that the groups are the same. If we measure everything, these two bell-shaped curves will line up and be equal. So I'm hoping I'm not confusing you. So that's an example of a hypothesis. So we want to test that hypothesis. So really in our research, that's what we're doing. We're testing a hypothesis. We do our study after we come up with research question, and we've come up with a hypothesis. We collect the data. We're going to calculate the statistics, and I'm going to do that for you guys. You just have to do the test. What we do is we either reject the null hypothesis. If we reject the null hypothesis, because our null hypothesis for our example, again, we'll go back, there will be no significant difference. If we reject that, that means that there was a significant difference. That means that the novice athletic training student and the experienced athletic training student was different. There was a difference between those two groups. Or we fail to reject the null hypothesis. So if we fail to reject, that means that the novice and the experienced athletic training students were the same. There's no difference between those two groups. And actually that's what I found in my study, that athletic training programs did not professionally socialize athletic training students. Novice and experienced athletic training students professionally were the same by the time they ended the program. A student came into a program and their professional socialization was not changed at all. Professional socialization is simply taking on the culture, the attitudes, and the beliefs of a particular profession. So, unfortunately, that's what my study found. I was not able to reject my null hypothesis. There was no difference between the groups. Now, how we make this decision is based on a statistical term called level of significance. That little symbol there is a Greek letter called alpha. That's why this is also known as alpha. Chapter 7 in the textbook talks a whole bunch about this stuff. Basically, when I get to the next slide, I'll kind of explain that. We generally select a 0.05 alpha. And what this indicates is that there is a 95% probability that the conclusions being reached are actually true. Okay, let me go to this normal bell-shaped curve here. Okay, if you look at plus or minus standard deviations there at the far end, we said that we have a 0.13% on either side of that standard deviation. Basically what we're saying is all things being equal, if we line up all the numbers and compare the novice and the experienced athletic training students, if the one group was different than the other, there would be a shift in this curve. That's if the curve was shifted, the mean really is shifted one way to the left or the right, there's some kind of difference there. What the alpha is really telling us is that we can say about 95% of the time that our numbers are correct, that statistically speaking that these groups are different or they're not different. It's kind of confusing. I'm hoping to show you that in our learning activity coming up here in a few seconds. Last word before I talk about the learning activity. Inferential Statistics, the chapter 6 in the book in general they use the term parametric and nonparametric statistics. There's a lot of different types of these different statistical tests, and it's really the type of test that we use is really dependent on your research question and the variables. I'm really going to help you with that. I'm not really a statistician, but I know enough about stats where I can make that determination and run the statistics. I've taken too many stats classes, so I can help you with that. Please ask me questions. I'll try to explain it to you in understandable terms. It's not the goal of this class to make you statisticians. When we talk next week about more of the different tests, I'm going to try to give you some background with the different tests and also provide you with examples from research problems that you can actually see what it's supposed to look like. It's not my job. It's not my heart's desire to teach you the math. I'm trying to teach you what the numbers mean. So that leads us into this learning activity. In the assignments link there's a Word document that has all this information on it. Why don't you pause this recording, this podcast, go to Blackboard, print out the learning activity so you have it in front of you so you can work along with me as I talk through this. Okay, we have a scenario here. A physician is evaluating a new diet for her male patients with a family history of heart disease. To test the effectiveness of this diet, 16 patients are placed on the diet for 6 months. Their triglycerides and weights, I assume that everybody knows what triglycerides, that's the fatty content in your blood. Their triglycerides and weights are measured before and after the study. And the physician wants to know if either set of measurements has changed. Okay, we're going to use this study quite a bit next week too. So, okay, what I want you to do in the learning activity is I want you to write a research question based on that scenario. Use the format for research question that I've provided you in the thesis examples that I've provided on the course documents link. Also from week 2 in the feedback I've given you from your learning activity too. I want you to write a null hypothesis for this. Remember, use the term significant. There is no significant difference in there somewhere. Your research question and your null hypothesis should be very similar. If you look at the examples, you'll see that they're very similar. I want you to identify the independent variable and variables and the dependent variables. Tell me what the population and or samples are for this, and tell me the level of measurement for the different numbers for this. Okay, that's one part of this learning activity. Okay, we use a statistical test. Okay, and we're going to talk about this test a little bit more next week. We used a dependent t-test, which is also known as the paired sample t-test, which again, this is a way to determine if there's a difference between group A and group B. And I'm not going to tell you the variables because I want you to determine that. We are comparing two groups. We had a pre and post-test score, diet scores on here. And we're testing to see if the diet made a difference in weight and triglyceride for these 16 patients. Okay, hopefully you have this printout in front of you. There's some critical numbers on these tables. This is actually from a computer program that I have. It's called SPSS. And if you look at a couple things here, I'm going to go over what this is. We have on the top one, it says pair sample statistics. We have pair 1 and pair 2. Triglyceride pre and triglyceride post. So we have mean n. N is the number of subjects, standard deviation, standard error of the mean on that table. Error is, pre-test, post-test. We have a pre-score of 131.25 mean. That's the average, whatever that number stands for. And we have a post score of 115.69. So the 16 individuals' mean score, pre-glyceride score was 131.25, and their post score was 115.69. Their weight before the diet, the average weight for this group of men was 139 pounds. Their post weight was 132.19 pounds. So if we look at their weight first, their weight decreased by 6.81 pounds. Their triglyceride levels decreased by 15.56, whatever they measured that in. Now, how did I get that? I took 131.25 minus 115.69, and we got a mean difference score of 15.56 for the triglyceride. And the weight, the same kind of thing. We take 139 minus 132.19 and got a score of 6.81. Okay? So that's what the means are telling us. It's descriptive statistics, really important. Now, if we look at the deviation, the standard deviation is for the triglyceride pre-score is a 40.7, and these numbers aren't too spread around. They're pretty close and compact. I don't want to get too crazy with the numbers there. Go down to the bottom table, paired sample test. Now we have pair 1 and pair 2 again. We have the exact same things as above, triglyceride pre and post and weight pre and post. And there's the mean. Now that's, I want to write this down on your paper there. That mean is the mean difference score. Again, that's what I just gave you. We minus the pre and a post test score, and we came up with those two numbers, 15.56 and a 6.81. Standard deviation, standard error, the mean. The key number on this table is, you see a letter T. It's the third one to the last on the right hand side. T for the triglyceride is a 1.202, and the T for the weight is 12.071. Okay, that's a critical number, and we'll see on the next page, on the next slide, what that looks like in writing. The last important thing on these tables is the one that says SIG, two-tailed. Now what I want you to do is write on that chart two things. The little letter, lowercase p, and that alpha symbol. That is the level of significance. And here's where it boils down to. If that number in that box, the significance box, is smaller, or excuse me, greater than a 0.05, then that means that the study that this physician did actually worked. Or in other words, if that P level, the alpha level, the significant level is greater than a 0.05, then we reject the null hypothesis. Whatever you come up with that, there was no difference between something. So if we look at this on the triglyceride level here, we have a significant level of 0.248. That number is, did I say that wrong? Sorry, the 0.05 is it's supposed to be smaller than 0.05, so smaller than a 0.05. That 0.24 is greater than a 0.05. That means that the triglyceride level, that diet did not make a difference in the triglyceride level at all. We fail to reject the null hypothesis. The diet did not make a difference with the triglyceride level on these 16 men. Where if you look at the significance level on the weight, 0.000, that is smaller than a 0.05, and so we reject the null hypothesis, and we say that the diet did make a difference on these individuals' weight. What this will look like in writing, we'd use tables to show the means, the standard deviations, standard errors for the test statistics. And you can look and see this on the different examples and different research studies. We want to use words to describe what all those numbers mean and tables mean. So here's some examples of how I'd write this up and how you are going to write stuff up in the spring for your chapter 4 in your research project or study. So post triglyceride measures were lower, M means mean, equal to, you can read the numbers there yourself, than pre-diet triglyceride levels. And we get the mean for a mean difference of 15.58, the standard deviation of 51.80 for these patients. And I'd put the table, whatever table we're going to include that as. Another way to write this is post-diet weight was lower than pre-diet weight for a mean difference of 6.81 with a standard deviation of 2.261 for these patients. Now notice I put the description, I give the number, I always give the, whatever it is, the post-diet weight, give the numbers, was lower than pre-diet weight, and give the numbers. And then I give that mean difference. Now here's what we conclude. It was found that there were significant differences in the pre and post weights. Now that T with 15 equals all that, that's the statistical test. So when you're reading research studies, when they do something like that in the journals, that's the statistical test they used with a P equal to 0.001. But that's the significance level. The P is, we typically have the P at 0.05. If it's lower than a 0.05, then we reject the null again. But there were not significant differences in the triglyceride levels. Again, we have the T, the 15's the degrees of freedom, which I don't want to confuse you with. I give the number from the table, then I give the P level 2.48 for these patients at an alpha level of 0.05. Again, we rejected the null hypothesis for the pre and post weights. That means there was a difference between the groups. We failed to reject the null hypothesis for the triglyceride levels because the diet did not make a difference for these patients. Here's the questions I want you to answer. What did this study conclude? How would you write the conclusion? So I want you to actually write a conclusion. Did the 6-month diet make any difference for these patients? Yes or no? And what can we infer back to the population? What can we say if we're going to go back to, we're going to write this in a journal, what can we say about this? 1 or 2 or 3 sentences here. What can we say about the diet, whatever that diet was? That's your learning activity 4. I'm going to talk about possible errors for just a bit. There's 4 errors that we can make in research. And the table there kind of gives us a picture of this. The book talks about this quite a bit. There's a type 1 error and a type 2 error. Okay, so on this table here we have conclusions of our test. On the left hand side going up and down, do not reject the null, which is called fail to reject the null, or we reject the null. So on the top is what's the truth, what's the correct thing. Okay, so in the first box, upper left hand corner, null is true, correct. Null is true and we do not reject it. So that's what we want to happen. What a type 1 error is, or an alpha, null is true but we reject it. We say that there is a difference but there isn't. That's the most common type of error. Type 2 error is alternative true but we do not reject the null. This one doesn't happen too often, and again chapter 7 talks about this quite a bit. correct the alternative truths, but we reject the null. Now let me just boil this all basically down to a few things. The whole point of this slide is that we want to make sure we don't make mistakes. That the study we design and the thing that we come up with is actually the correct answer. And how we actually keep ourselves from making the wrong decision in research is by designing good research. And the chapters after this is we talk about how to control our research. Some of those things we can't control for are called limitations, which is part of the thing that we talked about back in chapter 2. These are things, limitations are things that we have no control over. For example, if you're working with young kids and you have a study that lasts a couple months, young children are going to mature. Well, you have no control over that, and that can really hurt your study. So a lot of the things that we're trying to do is just controlling and designing our study in a correct and possible manner so we are making the correct decision. Do we reject the null correctly, or do we fail to reject the null correctly? So that's a nice thing there that kind of tells you a lot of things that I've already talked about. You can think about that one for a while. Basically, we just want to make sure that we design our studies correctly so that we reject the null hypothesis when it is correct. We haven't made a mistake. Just the big picture here is I want you to understand different levels of measurement, what statistics are used for, what are measures of central tendency, specifically what's the mean, measures of variability or numbers that are spread around the mean. Our standard deviation is the most critical, important thing. When we design a study, we design a study based on a research question and a null hypothesis. And a null hypothesis, again, is saying that there's no differences between whatever our groups or variables are. We design a study to test that null hypothesis. We control for all the things that can go wrong, so we make sure that the thing that we've done in our study is causing some kind of change or difference. We use statistics to determine if that study has made a difference. We base everything on this bell-shaped curve. And the bell-shaped curve, the normal curve, really is all the groups. If we put all numbers together, that's what most people would be like. And if our intervention or our study makes a difference, the numbers will be different and it'll be shaped differently, and we can reject our null hypothesis and say that our study made a difference. If you have questions, the book does a really good job of explaining some of this stuff. When you're done with this, I have one more part of this chapter 6 that I need to cover, things like populations and samples, so you understand what those terminologies mean. So give your brain a massage and get ready to listen to the next series.